This is part 2 of electrochemistry. So in this part we are going to discuss factors that affects electrical conductivity in case of electrolytic solution. So basically we are studying factors affecting electrical conductivity. So in this we have around 5 factors. So first factor is nature of electrolyte. So what does it mean? It means that if I have strong electrolyte, then conductivity will be high. Conductivity increases. Weak electrolyte, lesser conductivity. Now moving to, this is very simple, nature of electrolyte. So we have two types of electrolyte, weak electrolyte, strong electrolyte. So if we have strong electrolyte, then conductivity will be high. If we have weak electrolyte, then conductivity will be low. Now second factor is the nature of solvent. This is important, nature of solvent and viscosity. So in nature of solvent and viscosity concept, what we study, we see that if I have polar solvent, then the electrolyte which we are using will ionize easily. So I am writing here, polar solvent helps in ionization. So conductivity increases. If non-polar solvent do not help a lot in ionization of electrolyte. Now this is again very easy. Now in this as I have written in heading that viscosity. So in terms of viscosity, it's very simple. If I have viscous medium, means if a solution have high viscosity, if a solvent have high viscosity, then ion will not move easily freely in the solution. So if viscosity increases, conductance decreases. Conductivity is inversely related. So again this is very easy. Now moving to third factor is size of ion produced and solvation. This is again very important. Now what happens in this is, if I have a bigger size of ion, so it basically affects the movement of ion. So if I have bigger size of ion, or if ion is highly solvated. So what does it mean? Highly solvated mean, if I'm taking lithium ion, so basically what happens, oxygen of water get arranged around the lithium ion. So just because of this, it is highly solvated. Delta negative charge, delta positive, because oxygen have delta negative charge, so they basically solvate the lithium ion. This is lithium ion. So lithium ion is solvated. So ultimately effective size of ion increases. So solvation अगर increase होगा, if solvation increases, then what will we see? Conductivity decreases. So this is a very important concept. Now moving to next factor, that is temperature. This is temperature. So temperature concept is easy. If I have high temperature, so what happened? The high temperature decreases the interionic forces between ions. So just because of decrease in interionic forces, the ion can contribute to conductivity or flow of current. So what I'm saying, temperature increases. If temperature increases, then conductivity also increases. This is very simple concept. If temperature increases, so what happens? The interionic forces between the ions basically decreases just because of high temperature. So ultimately, what will happen? The conductivity will rise. Now moving to next very important concept, that is concentration of electrolyte. So this is very important. So in this case, what will we study? If I have weak electron, here we have two cases. For weak electrolyte, assume if I have AB electrolyte, so what will happen? It will ionize to A plus or B negative. Then what happen if I increase? Basically what I am doing, if I increase the concentration, if I add electrolyte, so what happen? Basically we are adding more number of ions, and we already have ions. So what happens? Just because of Le-Chatelier principle, by with the addition of electrolyte, the equilibrium will shift to that side which have lesser number of ion. If I add electrolyte, then we are adding more ions, more particles or ions. So equilibrium will shift to that side which decreases ion, which decreases the number of ions. So in which side this will happen? It will lead to backward direction, because in backward direction we will have lesser number of ions. So what we are concluding here, we are concluding with the addition of, with the increase of concentration, we will get lesser number of ions. So conclusion is, what we have concluded. Conclusion is that with dilution we are not diluting, actually we are increasing the concentration. So with increase of concentration, the conductivity decreases as we will not have, as we see the ion decrease. So as we see, we will have lesser number of ion by Le-Chatelier principle. So this is very important and also very easy. Now this is for, I have not written here, this is for weak electrolyte which doesn't ionize easily, or it doesn't basically dissociate completely. Now in case of strong electrolyte, the strong electrolyte is easy. So simple, here we have simple concept with as I've discussed in case of temperature, the same concept will apply here. So by by adding by adding more electrolyte. By adding more electrolyte, what will we see? We will see that the interionic interaction increases. Then interionic interaction rises up. Okay, so conductivity decreases. So to get high conductivity, if we want to have high conductivity, we have to dilute. As with dilution interaction decreases, so ions get free and contribute to flow of current. So this is very simple. And what we have discussed around 5 factors. First is nature of electrolyte. If we have strong electrolyte, the conductivity increases. If we have weak electrolyte, it will have lesser conductivity. Next is nature of solvent and viscosity. If we have polar solvent, then ionization will be easy, so conductivity generally increases if I have polar solvent. Now if I have non-polar solvent, so it doesn't help electrolyte to get ionized. So next is viscosity. Viscosity factor is very important. Is not that much important, because we all know that if I have a high viscosity liquid, then the flow of ion will be low. So next is size of ion produced in solution. This is an important one. If I have small size of ion, then the solution will be high, and if solution is high, the effective size of that ion increases. So it will not be easy for the ion to move on either side of the plate in the cell. Now next is temperature. Temperature factor is easy. If I increase the temperature, then the movement of ion will increase, then it will overcome the force of interaction, so it will become free to conduct electricity. Now next one is concentration of electrolyte. So in case of weak electrolyte, if I add more electrolyte, then the just because of Lee-Chatterjee principle, the equilibrium shift to the backward direction. In backward direction, we will have low number of ions, so conductivity also decreases. Now moving to next, that is strong electrolyte. So in case of strong electrolyte, the concept of dilution favors. If I dilute, if I have low concentration, then the number of ion will be easily available, because with the low concentration they will ionize easily. We will have lesser number of interionic interaction. So that is the concept in this. So we will study more concept in next video. Thank you.